Today we're going to finish section 3.1, Numeration Systems. And last time we actually started our discussion with Roman numerals. And 2 class periods ago, I had asked you to take a picture of or look very carefully at the clock on top of Rayleigh Chapel. Did anybody look carefully enough to recognize that there is anything unexpected about the clock on top of Rayleigh Chapel based on what we've learned about Roman numerals? It is in Roman numerals, but there's something about it that's different. They're not different. Do you guys have your pictures? Do you know what it is?
Isn't it that the 4 is like 4 lines?
Yes, it is. The number 4 on the clock of Rayleigh Chapel is written like this. How should it be written? It should be written IV. Interestingly enough, the 9 is written correctly, but the 4 is not. Isn't that interesting? It is. It's kind of interesting. All right, let's take a look then at our last 2 questions in our section of material. Last time, what we had done before we left is we had talked about how we change a different base number into our base system. Okay, so if you kind of can imagine, I'm going to give you a visual for what we're going to do that will lead very nicely into the other half of turning the numbers around the other direction. Imagine that somebody came in with bags of crayons. Okay, so we'll use the T00 as an example. They had, in this case, 10 bags. They had 10 bags of 144 crayons. And they dumped them on the floor. And you were trying to figure out how many crayons there were when you were done, right? This is exactly what you do. You would say, like, well, how many crayons do I have? Well, you'd literally count them in that case, and I understand that. But it would be the equivalent of doing what we did here. We multiplied 10 times 144, and we ended up with 1,440 crayons. Now, we're going to imagine we're going backwards in that case, okay? So I promise I'll go back to the instructions here in a minute. We're dumping 11,028 crayons on the ground, and we're putting them into bags. The bags we're putting them into, though, are base 4 size bags. So in particular, you have some that are just going to be leftover singles when you're done. You have some that are 4 to the power of 1, which is, of course, 4. You have some that are 4 squared, which is 16. You have some that are 4 to the 3rd, which is... I have 256 written down. I've run out of space, so I'm going to shift them all. Whoops. You might have some that are 4 to the 4th, which is 1,024, or 4 to the 5th, which is 4,096. But if you try to do 4 to the 6th, you get 16,384, and you don't have that many crayons. Okay, does everybody make sense of that so far? So these are all just whatever base you're working in, you write down powers of that base until they're too big. So we're going to have as many as possible crayons in as big as possible bags because it's going to minimize the plastic use, right? We're going to be eco-friendly today. Right, plastic bags, got to use a few of them. So we're going to have some bags that have 4,096 crayons in it until I don't have 4,096 crayons left. And then I'm going to make bags of size 1,024 until I don't have any more than that left. And then I'm going to keep going down this list until I end up with some single crowns left over or stragglers. Okay, so let's go back to actually the way that this works. When we are working from changing our base system into some other base system, we are going to consider the expanded form of the base. That's what I just did. I looked at powers of 4. That's considering the expanded form of the base. And then you're going to use a division scaffold. And I'm going to show you what the division scaffold looks like. Okay? So, all those values that are powers of 4 are going to be in your division scaffold. And you've seen this before when we worked with our other number systems. Do you remember my little top hats that look like that? I'll remember that? where I put the number, in this case, it's our 11,028 underneath here, and when I'm dividing by goes on the left. And then what it divides, what the value is, the quotient actually goes on the right. So how many times will 4,096 go into 11,028? How many whole number times? 2 is correct. And then what is 2 times 4,098?
11,033.
Try again. That's too big. Because I think you did times 3. We want to do times 2.
Oh, sorry.
It's okay. 8,000 what?
196.
96?
Yes.
That's not quite close. You got an error 2. You're close. Super close.
2 times.
2 times 4096.
Oh, 92.
92. There we go. That's okay. Okay, so basically what we're saying is that once we figured out I had these 11,028 crayons, I made 2 bags of size 4,096, and they're no longer a mess on my floor, so I'm subtracting them off because they're in baggies. And if I subtract 11,028 minus 8,192, what will I get?
2,836.
Yes, ma'am. And then we do it again with 1 place less. So now we've taken care of, I'm going to just kind of shade them off as I do them. 1,024 is next. So how many times will 1,024 go into 2,836? Twice. And that's actually 2,048. So what is 2,836 minus 2,048? Okay, so we take care of the 1,024, so now 256. How many times will 256 go into 788? It is 3 times. And 3 times 256 is?
760.
I think you can probably subtract that one in your head. It's 20. We don't skip any powers, though. So even if the number we end up with isn't big enough to actually go in any times, we're still going to use that power. I left one out. What's missing? Oh, that's not supposed to... No, what is missing? Oh, I got ahead of myself on my paper. That's what's missing. Let's do this. All right. 4 cubed is 64. 4 to the 4th is 256. 4 to the 5th is 1024. 4 to the 6th is 4096. And 4 to the 7th. I didn't have those pieces written down. I'm sorry. 64 is the next number. So I should be dividing by 64, but 64 doesn't go into 20, right? So I will have a 0 here, which is okay. And it does need to be there. 0 is a placeholder. As we found out in other systems, it causes problems when it's not there and it should be, right? But then I can divide by my 16. So how many times will 20 go into 16? I said it backwards. 16 go into 20? Yeah, once. So when I subtract, I get 4. I'll divide by 4. 4 goes into 4 one time. And I know I'm at 0, but I do not get to stop until I've divided by the number 1 at the end, even if I'm at 0 already. Of course, 1 goes into 0 0 times. The cool thing about the division scaffold, like the really cool thing, like you're like, oh, this is fantastic, is that the answer is right there. Highlighted in blue. The answer is 2 2 3 0 1 1 0 with the subscript 4 written down beside it. Just read it straight off of the division scaffold, which is fantastic. We're going to do another example of this, but are there any questions on this one before we do? Okay, so the next one is actually taking 99,999 crayons, dumping them on the floor, and putting them into the bags that have powers of 9, because this is putting them into base 9. So as with anything, we start with the number 1, and then the value of the base we're in, the 9. And then I have 9 squared. So what's 9 squared?
81.
81. 9 cubed.
729.
Yep. 9 to the 4th.
6,561.
9 to the 5th.
59,049.
And you're welcome to try 9 to the 6th, but you probably recognize right here that that's got to be as big as you can go, because it's already over half of what the number was to begin with. It started at 99,000. This is 59,000, right? So we're not going to need to go any bigger than that. So with my division scaffolding, my first number, 99,999, will be divided by 59,049. These are running into each other. So how many times will 59,049 go into 99,999? One, right? Nobody wants to talk to me. Okay, 1. Yeah, 59,049 subtracted off. So what is the difference in those numbers? Perfect. 40,950. And our next place value is 6561, 6,561. So how many times will 6,561 go into 40,950?
6 times.
6 times. And 6 times 6,561 is 39,366. Okay, working our way down the powers of 9. 729 is our next divisor. So what is 4,950 minus 39,366? 1584. And 729 will go into 1584 twice. When I multiply, that's 1458. For a difference of 126. The next power in my list is the power of 81, which just goes in once, exactly. So minus my 81. 126 minus 81 is 45. How many times will 9 go into 45? Yep, 5 times. And that's 45 giving me a remainder of 1, but don't stop until you're dividing by the 1, right? So there's obviously 1 will go into 0 0 times. But my last step is always to divide by 1. It doesn't always end in 0 like that. That just happened on my 2 examples. And our answer is along the right-hand side, right here in pink. So it's 162,150 base 9. Now I mentioned something last time and I want to draw your attention to it one more time. We started out, our 99,999 is a 5-digit number and it's in base 10, right? 5 digits in base 10. And what happened when we went down to a base 9 problem? How many digits did I get? More, right? 6 digits. I started with 5 digits in base 10, and when the base value went down, it's base 9, I ended up with more digits. And the same thing happened over here. I started out with 5 digits in base 10, and how many digits are in my base 4 number? A lot, actually, at this point, right? 7, yeah. So that always corresponds. Bigger base, fewer digits. Smaller base, more digits. Okay, those are corresponding to one another.